Our next two parent graphs are also related. Let's look at y equals x cubed and y equals cubed root. Remember, x cubed and cubed roots are inverses. They undo one another. So let's start with x cubed. I've drawn the t-table here and plugged in all of the some major points here. But again, our main base points are going to come from the x's 1, 0, and -1. So 1 cubed is 1, 0 cubed is 0, -1 cubed is -1. And those are the three that we see here in the center. Now notice they're in kind of a straight diagonal. So you're tempted to draw a straight line through them when we are making this graph. But actually, I always start in the center and it needs to be kind of curvy as you go up and it needs to be curvy as you go down. That is what this graph is actually going to look like. And if we go over to Desmos, again, I'm not the greatest drawer in the whole world. So if we go over to Desmos and we look, here is an example of that graph. And you can see the very curviness between 0 and 1. And then it kind of shoots up quickly and down quickly on the left. So different than a parabola, and a parabola goes up, up on both sides. This one goes up on the right and down on the left. If we go back and look at cube root, what you'll notice is the cube root of 1, 0, and -1 are exactly the same as x cubed, 1, 0, and -1. The difference becomes like the next thing you can take a cube root of is 8, and the cube root of 8 is 2. So again, you don't want to go straight through these, you want to go curvy. But notice this time we're going out in a more horizontal direction. This one is going to be long and low instead of tall and skinny like the x cubed was. So I always think x cubed, we're going to be tall and skinny. For cube root, we're going to be long and low. That is what these two is going to distinguish these two graphs from one another. And again, if we take a minute and look at that x cubed, you do see how it's curvy, it doesn't go straight through, and it's long and low. That's what this thing is going to look like.